So, hello, this is my presentation on probabilistic wildfire risk assessment using Monte Carlo simulation. Um, so, this is the problem statement. The problem statement is that there are a wide variety of physical models that are available to predict forest fires. The problem with these models is that they are based on physics, and then they're based on a very small availability of previous data because of very less frequent occurrences of forest fires. The thing about forest fires is that they're extremely stochastic processes, which essentially means that these processes and these forest fires depend upon a wide variety of factors and have extreme randomness involved in the process. These models do not really accurately assess the risk of a particular place uh, because of the skewness of the previous data and their physics models. As a result of which, our job and in this project is to use something called Monte Carlo simulation to sort of restore the randomness that is present in these natural disasters and use GANs to sort of simulate forest fires. So, what is our proposed solution? Our proposed solution is to use GANs, which is generative adversarial networks, to simulate a forest fire. We use Monte Carlo simulations for probabilistic risk assessment, which essentially means that we use Monte Carlo simulation to create a variety of random scenarios by randomly probabilistically changing the different parameters and then running these simulations on a GAN and visualizing our risk map in QGIS. So this is our proposed solution. Now the data that would be required for this is multifold. First, would obviously need like previous forest fire data, as which essentially means you need DEM maps and raster files that have the data of where previously the forest fires have occurred. You also require data of different fuel types, so the type of land that you have, the forest coverage, etc. That would be required to make sure that you have an idea of what fuel types exist in a particular region that can probably lead to the widespread of a particular forest fire. So there are multiple websites and multiple organizations that actually publish data like this. So NASA has their own for historical forest fire data, as well as they have their different terrain data from the different satellites that they deploy. So the methodology we are going to use for this is we are going to create a wide variety of situations using our probabilistic Monte Carlo formula, and we are going to pass those input parameters through a GAN and eventually get an output as a risk, a probabilistic risk map for a particular region, and we are going to eventually sort of combine the various risk options obtained from different scenarios and different inputs and visualize them on QGIS. So this is what our technical architecture is going to look like. Our technical architecture is going to have the first step is obviously going to be data collection. We are going to be required to collect data from the different sources that we have and pre-process it and some pre-process it to get the relevant information. Then we train our GANs, which is essentially going to take in the input parameters such as wind speed, fuel density, forest coverage, etc. And then we are going to use the Monte Carlo formula to probabilistically vary these inputs. And then based on these, we are going to run a simulation, our GAN simulation, to get the final probability map of a particular region of what percentage possibility is there that there is going to be a damage in that area. And then finally we're going to use QGIS to create these detailed risk maps highlighting risk and high risk fire zones. So the potential for application of this solution is that this could essentially enhance your wildfire risk prediction It's probably going to enhance what is the probability of a particular forest coverage to be damaged by forest fires. It also gives you a better risk assessment than the previous ones, and gives you a better early warning system, so that you can probably evacuate the residents in time. Also, it's a very good environmental monitoring technique to track wildfire patterns and probably predict future wildfire patterns depending on this. And it can also help in urban planning. So, probably certain areas which are not identified as risky depending on previous models could be again evaluated when we're using this, and then reevaluated using this solution, and then worked upon. So this was my presentation and my solution for the given problem statement. Thank you.